This is a impulse momentum problem from the Walker textbook, and it involves a crash with a race car driver hitting the wall, but it's a two-dimensional problem. So it's pretty complicated because it's got a collision where the race car driver is coming in at this angle of 30 degrees and then kind of bouncing off the wall and coming off at an angle of 10. So the original question here, part A, is what is the impulse, which we're using a capital J to represent, on the driver due to the collision? And in this case, we're just, I guess, worried about the driver, not the car and the driver. But in any case, we have the mass of the driver, but we don't have the force. So the formula from AP is for J is technically the integral of force with respect to time. So that's one way to find this. But it's all the other way to find this would be change in momentum. So that's going to have to be how we find it in this case. And then you'll see that in part B, we are given the time and asked for the force, the average force. So we'll end up finding that later. So for this case, we're going to end up splitting the velocities into x and y components, solving for each change, the change in the x velocity and the change in the y velocity, and then using Pythagorean theorem to find the overall magnitude of the change of momentum. So if we split, I've got the protractor in here just to prove to you that we've got a 30-degree angle and a 10-degree angle. That's like the luxury of having this tool here. But I'm going to get the protractor out of the way so that we can draw some components onto here. So we would have the x component of velocity and the y component of velocity here. Let me try to make this disappear. Okay, so then we will have, this is initial velocity here, and then we would have v, these are probably extraordinarily long, but vix and viy, and then the v final in the x and v final y. Oops. Okay, and then we know that these are 30 degrees and 10 here. Okay, so let's find let's split these up into x and y. So x component, or maybe I should say just x momentum. Okay, so I will have the mass times v f x minus v ix. That would give me the change in momentum in the x direction. So that would be 80 kilograms, okay, times, and then the final velocity in the x direction will be the 50 meters per second So that's this one. The final is the hypotenuse there, times VFX is going to be the adjacent to that 10 degrees. So then I would want to do the hypotenuse times the cosine of 10 degrees, oops, minus 70, that's the original velocity, times, now if I'm looking here, yes, again, that is going to be that initial velocity in the x direction. Okay, so when I do all that math, I get that the change in momentum in the x direction is negative 910 or 911, but for sig figs, I'll just go with 910 kilogram meters per second. And then in the y direction, I'm going to repeat this process, and let me give myself some more space here. So then that change in momentum should be just like that, only now I'm using signs, so okay. And I'm just checking here the change in direction, because initially the driver was coming, let's see, if I'm looking at the y direction here, which way is positive? So if I am gonna go into the wall, should this way be positive? So pick a direction here. Usually I would say this up is positive, so this is positive, and this is the negative direction. And I just want to make sure that, like when I do 50 times sine 10, yeah, I want to put like a negative sign in front of that, so that I'm acknowledging that that was a definite change in direction. Whereas in the x direction, that the car was going the same direction the entire time. So okay, there's a negative sign there. It's not very obvious. Okay, so let's do the math now. So okay, now I get negative 3,500 Okay, and that acknowledges again that the car is now has experienced a change of direction. It was going in the positive direction, and now in my coordinate system, it's going in the negative y direction. So now I'm still not done because I've done the x and y, but they asked me for an overall impulse change. So to get the overall, I have to do Pythagorean theorem and do jx squared plus jy squared. Okay, so do that stuff, and negative 910 plus negative 3,500 squared. And when we do that, then we get a magnitude of, according to the book, 3,600. So that 910 doesn't make much of a difference. Okay. Now, technically, we're supposed to give an angle as well. So again, I'm running out of space. Let's do this. So when I do that, sorry for all the interruptions, then I could do inverse tangent to figure out the angle that this impulse is being exerted over. So then I would say, oh, sorry. That I'm going to go inverse tangent of the y over x would give me the angle. And when I do that, then I get 75.4 degrees. So what that's telling us is that the change in momentum is opposite to, if we put the protractor back up here, let's do that. Yeah. Okay. Okay. So, and I'm going to drag this. Okay. So the car, if it would have kept on moving, it would have had this momentum in this direction, but it then changed and hit the wall. Instead, it went off in the red direction. And so the overall change was 75.4. So if we look at, let's line it up with this. Now it also has to do with the speed, but then we get this 75.4 degree change in momentum. Okay. And then finally, the part that you're going to need to know too for impulse and momentum is once you have the change in momentum, then we also know that the change in momentum is the integral of force with respect to time, or if you have a constant force, it is equal to force times change in time if the force is constant. So when they say average, if you have an average force, you can just use the constant number. So since we have impulse here, and we have a time that they give us. Now it's in milliseconds, so let's put that into regular seconds. Then we can solve for the force in newtons. So let's do that, divide both sides. And we get a huge, huge force, which is really bad for you. So when you do this, then you get 2.6 if we round times 10 to the 5th newtons. So that would be, if that truly actually happened, then that would kill the driver. So obviously we don't want that collision to last such a short amount of time, and we would want airbags, etc., something to make that collision last longer. Okay,